my name's Timothy Pulliam. I'm a senior sysadmin. That's not really important, but today we're going to talk about LangChain, and this is really kind of an introduction. So I've just been kind of getting into LLMs, LangChain, and stuff. So this is kind of going to be just an introduction. And I put the Python notebook in the chat if anybody wants to follow along. You'll have to create an OpenAI API key to follow along. And I'll also throw some resources, some links in the chat later for things that I was researching.
So there's a lot of chat.
There is a lot of chat. Yeah. All right. So just to kind of go over, so these are some links for LangChain documentation that I was following. This is a really good website, promptingguide.ai is like introduction to prompts and stuff like that. And we'll kind of touch on that a little bit. That's another good resource. And then also the OpenAI API reference sheet is really good too. So those are some good links. Just kind of giving some overview, broad overview. With regards to LLM, typically when we talk about a token is going to be a word or a part of a word, and you can kind of guesstimate it as being about 4 characters on average. That's a good kind of measure. Temperature is basically determines the randomness of the LLM. A temperature set to 1 is going to be more random. Temperature set to 0 is going to be more determinant. And then there's some definitions for top K sampling, top P sampling. We won't really be touching on that so much. But another good thing to know is what the context window is. And basically the context window is the amount of tokens that will fit into the LLM. It's basically the number of tokens that it's considering at any given point in time. So if you want to feed large documents into an LLM, you need a larger context window. I think the new Claude v2 has like 100,000 tokens context window. So it's like tens of pages probably. It's still not huge. And there's problems with larger context windows, which is it starts to hallucinate if you try to throw too much information into the context window. So that's good to know. Here's some examples of tokenization, just to kind of give you a feel for it. So you can tokenize by word. So for example, the quick brown fox jumps over the lazy dog. It's been tokenized into each individual word. You can tokenize by individual characters, by subwords. So like unhappiness is tokenized into, it's basically its most fundamental semantic meaning. I'm not a linguistics expert, so I'm not going to pretend to know all of this stuff, but that's kind of just like to give you an idea of what tokenization is. Here's some pictures of context windows, just to give you like a visual idea of what a context window is. Basically, again, it's the number of tokens that the LLM is considering at any given point in time. And then here's kind of an overview of like how we can consider our LLM behaving. So we put in a query. It's going to look up any relevant documents. It's going to retrieve any relevant documents from the embedded database, the vector database. And then it's going to return that with the query to the context window. And then from the context window, we get the final answer. So that's kind of like a high level overview of stuff.
So I think it's important to point out that the vector database isn't necessarily part of the LLM.
Yeah, no, you're absolutely right. It can be definitely separate, like a distributed thing. Yeah, that's really important. Although it's kind of hard to, when you're just doing LangChain, it seems like it's connected.
Okay,
but yeah, you're absolutely right. So LangChain. So LangChain is based on the idea of a chain, and a very simple chain is a prompt template, which you feed into a chat model, which you then parse the output of, and that's how you get your final response here. And so we'll run this one real quick. So basically, oops. Oh, because yeah, I need to install LangChain core probably. we're gonna do some live
Awesome.
demonstrations, which always goes smooth.
Oh, absolutely. Every time.
All right, so basically, yeah. Oh, did you?
I was just gonna say, while we're at the beginning here still a bit, just to add a little bit of flavor to that intro, the temperature, another way to think about temperature is creativity. Randomness equals creativity. Like how much it hallucinates or creates out of what it adds more, which is helpful when you're doing things like creating a story, like tell it to ask it to tell me a story. But if you want an answer to a more defined problem, on a logic problem, you don't want the creativity.
No, that's absolutely true. And so, yeah, no, that's a great point. And so for this one, I'm having it tell a joke. So I set the creativity high because
Nice.
I figured that would make it more funny. So here's a joke. Why did the ice cream truck break down? Because it had too many scoops of ice cream. Hey, I didn't see these jokes would be funny. Okay.
Yeah, but scoops.
Yeah.
Air quotes are
So yeah, it's not a great joke, and I think if you if you primed it a little bit better, it might tell a better joke. But this is just to demonstrate the idea of the chain, which is so we have a prompt, which is a prompt template. If you work with like Jinja templating, or basically it's an F string where you just are going to fill in a variable where it says, tell me a short joke about topic, and we're going to fill that in. And then the model we're defining to be, we're using the chat OpenAI model, GPT 3.5 Turbo, because it's free. So that's why I use that. And then temperature 1, because I wanted some randomness in the joke. I thought it might make it more funny. Obviously, that wasn't the case.
Can we run it with temperature 0?
Yeah, we could. I'm kind of interested what that
If
would be.
we can realize.
Yeah, I had too many scoops. It's really obsessed with scoops.
We said the thing again with the word "get it."
Yeah.
I like it.
Well, I guess this kind of demonstrates one of the problems with. So this is basically what's called zero-shot prompting, which is it's basically a cold prompt to the AI. It doesn't have any context. It doesn't have any message history. So it might make it more funny if we had like done a few shot. We give it an example of a joke, an example of an output that it should do, and then we might arrive at a more funny joke. But then this output parser is just going to basically turn the output from the model into a string so we can print it. And then we do this chain. So basically, if you're familiar with Linux at all, this is kind of like piping. So you're piping the output of one command into the input of another command. So we're taking the output of prompt, which is going to be a chat template, and we're going to pipe that into the model, which takes in strings and chat templates, and it outputs a message, which we parse into a string. I'll get into that in a second. So basically, and then you invoke the chain by calling the invoke function and filling in the variable. So let's kind of break this down a little bit. So let's first talk about the prompt. So this is what we would call zero-shot prompting, which is basically just a cold prompt on an AI which hasn't really been primed in any sort of way. So prompt is a base prompt template object in LangChain, which means it takes a dictionary of template variables and produces a prompt value. And then the prompt value is a wrapper around the completed prompt that can be passed either to an LLM, which takes a string as input, or a chat model, which takes a sequence of messages as input. And I just copied this from the documentation, basically just to kind of give you an idea of like all the bits and pieces that go into LangChain. So there's a prompt, which takes in a dictionary to basically fill in the variables of the prompt. It outputs a prompt value. There's two distinctions between chat model and LLM in LangChain. We're working with chat models because we're going to be considering message history. And so we're going to work with things called messages, whereas an LLM is a client object that just takes in a string and returns a string.
Transactional.
Yeah, basically. They basically kind of function the same way.
Yeah.
But we're going to be doing chat models just because.
Anything about chat is like just sending more and more context to the LLM every time.
Yeah, and basically what we're going to do is we're going to take the input, our prompt input, and as well as the AI's response, and we're going to stick that in a list of all the messages every time, so that every time we call it, it can look at the message history and it has some context about what we need to ask it or what we have asked it, and I'll show that again. And then there's output parser, which just takes the output and stringifies it, and these other things, which we might talk about the tool one later. But so far, we're only working with prompts, chat models, and output parsers in our chain. And it's important to note that these objects, they all share a common interface, so that for example, you can call the invoke method on all of them because they all share what's called the runnable protocol. So they are they have a very similar interface. In fact, they have the same interface. And I show that by first we're going to work with the prompt, and we call invoke on the prompt, and we pass in the topic of ice cream. And then when we return the prompt, we get a chat prompt value, which has an attribute messages, which is just the list of messages. In this case, there's only one message because that's the one we passed in. And if we do prompt underscore value to messages, it returns the list of messages. Because again, we're working with a list of messages, which is basically our history of the conversation. And then we can return prompt value to string as well. And it just gives us the stringified version of it. So here's an example of few shot prompting, where we've loaded in some messages into the history just to kind of prime the AI a little bit so it knows what we're talking about. And there's basically three types of messages that we're going to be working with. There's a system message, which is just like, it just kind of primes the whole AI, like you are a helpful AI bot, your name is name, and that way it has some background. And then there's a human message, which is our prompt. And then the AI message is the response back from the AI. In this case, we've already got a conversation started so that when we run this, when we ask it, what is your name? It says, my name is Bob. How can I assist you today? And then we get some response metadata. Finish, reason, stop just means that it stopped. And so yeah, that's basically how prompt templates work.
So it's like associating the messages with like an entity, I guess.
It's basically a list of F strings or
Yeah.
like, like format strings. You
Yeah.
can think of it like that. Yeah, and it really, well, it's a tuple because it tells you what kind of message it is, and then the actual template.
But for the kind of message, can that be anything? Like that's up to,
Yeah, I mean,
it's like these words, system and human and AI, do those have any meaning, or could those be any?
those I think are used by LangChain itself.
Those are, okay.
So yeah, you have to set those. But for example, when you call, and I'll show this later, when you call, if you don't use LangChain and you instead use the OpenAI client itself, it's called user role or role. It's called something different. So yeah, this system, human and AI, is specific to LangChain.
Yeah.
If you wanted to call the OpenAI API
Right.
directly, it would be something different. And I can show that in a little bit. But yeah, for now, it's going to be system, human, AI. So we've got a system, or we've got the chat primed a little bit. So let's move on to the model. Model is pretty straightforward. It's just, we had defined it up above, but we can also call invoke on the model. And we were going to pass in the prompt value. So basically, we're just looking at each stage in the chain, and we get back, I'm just going to minimize that. We get back an AI message, right? Because I said we're working with human messages, system messages, and AI messages. So this is an AI message with content. Why did the ice cream truck break down? Because it had too many scoops on board. not a great joke. So yeah, basically this is just showing that we can call invoke on any parts of these of the chain because they'll share interface. If so this is an example of if we had used an LLM instead of a chat model, it just returns a straight string. And if I had actually run all of these, sorry. Yeah, so this is just showing that we get, if we work with LLMs instead of chat models, we just get the raw string. There's no message.
That's fun here.
Yeah. Because yeah, okay, that one's a little bit better. So yeah, maybe use the LLM if you want funnier jokes or you're writing for a comedy show or something. And then lastly is the output parser. So we're going to take this AI message and we're going to run it through the output parser, which is just going to stringify it. So if we run that, I need to call these, sorry.
Now, I see you used a slightly different model for that last one, the turbo instruct.
Yeah, I just copied that from the documentation. There's
Okay.
no reason.
Okay, but was that the same that you used above?
No, the one I'm using above is just the 3.5
Turbo,
turbo.
not-
This is the 3.5 turbo instruct. Yeah, I'm still learning all the different LLMs.
Yeah.
It seems like there's a lot of
Yeah,
different
there's a
ones.
lot of flavors.
Yeah, it's kind of like Linux in that regard. There's a lot of stuff. But yeah, it's very interesting because of that. Yeah, and so this is the stringified output. And then this is just kind of a summary. We can run invoke on any part of the chain. And so this just kind of shows we call invoke directly on the prompt. We can pipe prompt into model and then invoke, or we can set the chain, the whole chain with the output parser and invoke on the chain. So that's kind of just like the overall idea of a chain. So if we wanted to make like a simple chatbot, for example, we would do something like this, where we have our prompt template, tell me a short joke about topic. We have the model set and we have the output parser. Our chain is going to be the prompt piped into the model, piped into the output parser. And I basically just run chain.invoke in this while true loop. And then we can ask it jokes. Is not callable.
Topic is not defined.
Wait, hang on. Sorry. I think I broke it probably. And it is not callable. Oh. Wait. Hang on, sorry. I'm gonna try to troubleshoot this here live. Yeah, topic is going to be the thing that we get as input. Why is it complaining about
Where
this?
does input come from? Is it important? Is it?
Input is the, go again about the input? It's topic ice cream that you had from before. So it's
Oh, that's okay,
not,
so it's pulling
Yeah.
stuff from the previous.
Oh.
Yeah, so that's not yeah.
Okay.
I think it's expecting it to be a method as opposed to a dictionary.
Yeah, I see. Yeah, sorry. I guess I didn't.
But no,
it's
so it's
input
square brackets instead of parentheses.
on the input.
So the input, you might be expecting it to be something different, but I think you overwrote.
Oh. I see.
Well-
Yeah, we can.
How many places have you used input?
This is what I'm gonna do. I'm just gonna restart the kernel, right? Can I do that? Restart session. All right, sorry everyone.
You might just want to do like a search of the word input and see.
Where did I call that?
Oh, inpug.
Oh,
You misspelled input in your search.
oh, I did. Sorry, I can't see it. Wait. Hide video panel. Do you know how to?
You can just drag it.
Oh,
Grab it from the Green cake.
Oh, okay, sorry.
It's funny, we don't see what you see.
Yeah.
This is very weird.
Great. Well, that's user input.
That's not it. That's not it.
Oh, yeah.
There's input, yeah.
Dang it. All right. So I think what I can do is I can just
Maybe input, you change that with the input data or
Prompt
something,
input.
or prompt, yeah.
yeah, I'll do input topic. I thought I had ironed this out a little bit better, but I guess I
Oh,
didn't.
good.
All right, and then I'm gonna restart the session just in case. All right. So let me just do all these imports and stuff.
Maybe the first one. Oh, at the
Oh.
top.
Oh, yeah. Good thing we have a lot of time.
So, oh, good.
In the meantime, can you repost again the link to the collab?
Yeah.
Because it's not there.
Yeah, I can do that.
It's because I
We
logged in
joined
after,
later or
yeah.
something, we don't
Yeah.
see we can't see the scroll back.
Thank you.
Yep, there you go. No problem. All right. Cool. Import the guy key. Just gonna do that one also. I don't think I need that one, but all right. So a simple chatbot. Okay. So until I type in exit, it's gonna basically keep telling a joke about something. What do you want to hear a joke about?
Python.
Python.
Why was the Python programmer unhappy? Because he didn't get a bite. Wow, that was great. Do you want to do another one?
What about LLMs?
Why did the LLM go to law school? To become an MA, Master of Arguments. Okay. I don't know if that really makes sense, but
Is an LLM, maybe it's a legal acronym and it pulled the wrong thing.
No argument is a part of the sentence. So it might be that. I don't know, that's how I say it.
So yeah, that's basically that's with a template. We can also just not use a template, and that would allow us to put just really anything we want. So we could ask it any question. So I'm gonna ask it, I don't know, what should we ask it?
How do you make a cake?
How do you make a
Lemon cake.
It's going to think, it's going to give us a recipe. I don't know if I'd use that recipe without at least looking at it. But the thing I wanted to show you is, okay, so we have it, we asked it to make a cake. If I now ask it, what did I just ask you to do? It's not going to know because it doesn't, yeah. So you asked me to identify.
That is
That's
awesome.
Which is technically the truth. You know? So it's not wrong, but that's not what I wanted. So basically, it doesn't have any memory of the conversation. So we want to keep track of all the messages that we're using. And so to do that, we're going to, from LangChain core messages, import human message and system message. And then we're going to get AI messages output. But I basically just wanted to set a system message to let it know you are a friendly chatbot assistant. You should help the user to the best of your abilities. If you are unable to answer a question or you don't understand the user's input, you must tell a joke instead. I thought that would be really assertive. And then we take that system message and we stick it into a list of messages, or you call it history, chat history, or whatever.
Yeah.
And then we're going to do the same thing.
Sounds like Nigo. We will best of
Yeah.
ability. If you can't, just make a joke.
Exactly. So I'm just going to type in gibberish and it should tell a joke. Why did the scarecrow win an award? Because he was outstanding in his field.
Yeah.
I like that one, actually.
That's an acceptable joke.
So we can also, we could ask it to do other things, but I'm gonna ask it, what did I just ask you to do? And because we were keeping track, oh, well, it's gonna tell the same joke again. Let me ask
Oh,
it.
because you didn't ask anything.
That's
Yeah.
that's technically true. Let's ask it again. Oh, well, this didn't happen when I was testing it.
Did we
Try-
leave the
try a
temperature at
cake.
0?
And then change it to a chocolate cake.
Okay,
But just saying, but chocolate.
okay, I like that actually. I love
No,
chocolate.
just bake a cake.
Bake a chocolate cake.
Yeah, how to make a cake.
Oh,
Just how to make a cake. He's gonna give you a recipe. And then you say just, okay, but chocolate. I don't know, something. like that.
okay. I'll say same, but
Yeah.
with chocolate.
Is it chocolate involved?
And it looks like it understood to make a chocolate cake.
Yeah.
So I said the same.
Yeah.
I said same with. I tried to be intentionally vague because I wanted to see if it
Yeah.
could infer, and it can. Obviously, still not great, but
What's the difference? You're not gonna.
No,
uh,
that's a good question.
He's
between.
gonna respond, duh.
So I asked you, what's the difference between the two recipes? And it's really stuck on this scarecrow joke. I think probably I could have used a better system message or something, but
Yeah.
yeah, it's because it's going to default to telling a joke every time. You don't have to do that. I just thought it would be funny.
It's interesting. So you're actually passing it the full conversation.
Yeah, so if we so what I can do is I could print the messages that we have so far. We can see what that
Yeah.
looks like.
I'm surprised it didn't pick up on the two recipes.
Yeah, so okay, so this is the list of messages. There's a system message here, which we started with. There's this human message, which was the content that was gibberish. And then this is a response. And then oh, you know what? I wonder. It's probably it
Oh.
looks like because it's not, yeah, I didn't
You only captured the prompts and not the responses?
Yeah.
well, I captured. Did I capture
It
those?
doesn't say system in front of I'm sorry, AI in front of the AI response. Like,
Yeah.
it doesn't tag it.
I think yeah, this is supposed to be an AI message and it looks like it's a raw string.
Yeah,
So that probably had something to do with it, right? Because see, like this is, whoops.
so he doesn't know what recipes you're
Oh.
talking about because he doesn't have it in his system. The recipes
Yeah.
that gave us.
Yeah, so what I probably should have done was like do AI message here and then convert this to an AI message. I'm not gonna mess around with it, but yeah, you could see kind of the gist of how it goes. There's different types of messages. You're gonna keep a history. And yeah, so basically the message history is just a list of messages. LangChain has this thing called ChatMessageHistory, which I didn't use, but you can use it because it's basically the same thing. It's just a list of messages. And you can use these add user message, add AI message. There's no add system message. But actually I wouldn't do this anyways, because if you look at the code, the source code, it tells you not to use it. So for example, add user message, convenience method for adding a human message. This method is deprecated, maybe deprecated in a future release. So I wouldn't really do this, but this is just showing that you could do it if you wanted to.
Make your own.
Yeah. And this is all kind of part of a bigger point that like LangChain is really just like a thin wrapper on top of some like Python classes and the OpenAI client. It's really not adding a whole lot. Really the main benefit of using LangChain is that it can work with different models, and then you wouldn't in theory have to change your chain at all because it works the same whether you're using like OpenAI or Claude or whatever model it supports, because you just have to change the model parameter and everything else should still work. But it's just really a thin wrapper on top of everything, and you could probably implement this yourself, and you may want to at some point if you want to do like some customization. And we'll get into that a little bit more. I'm just checking how we're on time. Okay, we're doing pretty good. So a cool thing with LLMs is this thing called retrieval augmented generation, which is basically you can tell that LLM to go out and fetch a document, like fetch a website or a text file, load it in to a vector database, and then it can use that as context and reference it in the future. And this is a prompt template that I stole from Langsmith. If you're not familiar with Langsmith, it's pretty cool. There's a lot of prompts out there. It's basically, Langsmith is like kind of like an IDE, I guess, for LangChain. You could think of it like that. But it's also a website, and they have this thing called the Hub, where people have published the prompts that they create. And there's some interesting ones there. And this is just to kind of give you an idea of like what is possible. So for the one I used just here, I looked in the category of chatbots. There's some really cool ones, like you could do an onboard email message. There's another one that I showed. Oh, this one looks pretty cool. I haven't tried this one, but Pizza GPT. Basically, it's a prompt template to get someone to fill out their pizza order. So like you can see there's a lot of applications here and very interesting stuff. And this is the one that I stole from somebody else. I tweaked it a little bit, but it was.
To be fair, you also use brag in your chat. In like the instructions that you gave it is technically RAG.
Yeah, I guess you could think of it like that. I didn't consider that, but that makes me feel better.
Yeah.
Yeah.
Yeah. Basically, any instructions that you give outside of the raw prompt is a RAG motion.
Okay. That's very interesting. So I tried to I try to keep everything clear here. I've got some comments, but so from LangChain document loaders, we're going to import the web-based loader because we're going to import from a website. And this is just the text file of Alice in Wonderland because I figured it would be pretty good to use. We call the loader, or we instantiate the loader with the URL, and then we actually load it. So data is loader.load. And then the next thing we need to do, because it's a really big document, we don't want to feed the whole thing into a database. So we're going to do what's called chunking. We basically split the large document into a list of smaller text components. And so for this, because it's a text file, I'm just going to use the recursive character splitter. There's many different kinds of chunking, and it's like a whole thing is to find the optimal chunking strategy. I'm not going to get into that because I don't really understand it too much, but because this is just a text file, we can use recursive character splitter. It's just going to split on new lines and stuff like that. So, for example, I'll show you what one of these chunks looks like. Oh yeah, it's probably gonna come here. Give it a minute. No. Did it print? Oh, yeah, it printed. Okay, so it printed the length. That's not what I wanted, actually. I wanted to print all splits. So this is the list. So let's try that again. So basically it broke up the one document into 400, or wait, all splits. Oh no, this is the length so basically, because I told it to chunk, the chunk size is 500. It split each sub document up such that they're less than or equal to 500. In this case, it's 488 characters long. And here's one of the chunks with the page content, basically the start of the book. And
yeah, it's the first page.
Yeah, it's basically the first 500 characters, and there's some metadata attached to it, which is the source. So
yeah, it's the level of content.
Yeah, So that's kind of one, actually, let me just show you all the splits because that might make it more clear. It's just a list of document objects where the page content is the text and then the metadata is the metadata. So this is a list of document objects. It's very long. I'm not going to go over the whole thing, but yeah, you kind of get how it did that. And so now we've split it up. We had this big text file and we split it up into a bunch of separate document objects. Now what we need to do is we want to store that in a vector. So excuse me, we want to store that in a vector database so that we can retrieve it later and we can do inference on it, basically. And so the way we need to do that is we need to embed it, which turns it into a vector. And a vector is basically just an array of floats. It is basically what it is. It's just a mathematical representation of the text. So we can mathematically compare different texts. And so that's what, and so I'm using, so
I think that we should talk about that a little bit
Yeah.
more, just explain what that vector actually is a representation of the meaning of the sentence, of the meaning of the text. So it's literally you can think of it like a line, a vector in math, where its direction is the meaning of the content. And so the vectors, if you have a second sentence that's talking about similar things, the angle between the two vectors will be small.
yes.
If it's talking about something radically different, the angle between the two vectors will be wide.
Yeah. And like, just to kind of give you an intuition for what a vector is, it's basically an arrow in space, which has a length and it has a direction. So for example, if you're driving your car has a velocity. The velocity vector is pointing in the direction of your car, and the length of the length of the vector, the length of the arrow is going to depend on your speed. So like if you're going faster, it's longer. If you're going slower, it's shorter. Except we're not doing that in 3 dimensions. We're doing it in 700, 1,000
Yeah.
plus.
Yeah, I think the default for a lot of things is 1,000, over 1,500.
It's over 1,000. Yeah. Yeah, and I don't know if we'll get to that, but I did try out Redis vector database because I was interested in it, and I got a very simple thing working. We might go into that, but and in this case, so LangChain offers many different embeddings. There's many different algorithms and stuff to embed. Since we're using OpenAI, we're just going to use the OpenAI embedding because that makes sense to me. And we're gonna store it into this vector database called Chroma, which is kind of like it's just built into LangChain. I don't know if it's production ready, but yeah, it's pretty easy to set up. And so basically, we define this vector store Chroma from documents, and we're gonna pass in that list of documents from the book, and we specify the embedding, which is the OpenAI embedding that we're using. So now it's in our database as a bunch of as a vector, a bunch of floating point numbers. So to use this prompt,
I just got a question about that.
yeah,
The sentence, or so you get a chunk. Is there one vector per chunk, or the vectors come out of the model figures out how to take the chunk and converted that into some number of vectors?
Oh, so when you're creating an embedding, you're creating an embedding for a string. So it depends on what they use with, if they're creating a series of vectors or a single vector. Generally, you can think of a vector as just another column, and it is a text representation. It is a representation of some string of text. What this particular database is doing, it's kind of hard to tell. And do you know?
I'm not sure what this one is doing, but I did want to show an example. Redis has a pretty good it has an example of what a vector would look like. So I'm gonna see if I can pull that up real quick, and it kind of, I found it to be pretty helpful. So like, yeah, not all this. Actually, this was not it. Hang on, sorry.
That's, I didn't know Redis got into the vector.
Everybody's getting into vectors. Any data store is getting into vectors these days.
Oops.
I've been using OpenSearch recently.
Yeah, and oh, maybe it was here. Yeah, I think this was it. From what I understand, vector databases have actually been around
Oh, yes.
for a little bit. It's just that now they're getting very
Somebody
popular.
found the killer use for it.
Yeah,
Yes.
yeah. In conjunction with LLMs.
So this is the way that Redis does it. This is just in their documentation.
Yeah.
So for example, if you had a bike that you're trying to sell, and that bike is, it's a product with a description, and you want to recommend products to people based on the contents of the description and things that they've bought in the past, you could embed the description of the product and then infer on that. And this is basically the way it gets stored in Redis. So you have the model, which is a string. Basically, the bike object is a string. The description is just raw natural language to describe it. And you take that description, because that's the thing that you want to infer on. And that's the thing that you've embedded here. And there's all these floating point numbers. You can see that's what it looks like. So that's kind of like what
So is there the length of this description embeddings is going to be the number of dimensions?
Well, yes, the number of dimensions, but that is a fixed number.
Yeah.
Oh, you're always gonna get the same length. All right.
For a given, like, I don't know.
It doesn't matter if you pass it a single word.
No, but like, is that dependent on the model?
I think it's
yeah.
depending on the embedding you
Yes,
use.
it's the embedding model.
Yeah.
So in this case, we're using the OpenAI embedding. So it's going to be a certain length. I don't remember off the top of my head, but if you used a different embedding, it would probably be the same, or it might be different.
And really, the database doesn't care what the contents of the vector are, or even how long it is. You do have to tell the database oftentimes how long you're going to store, just like how long your string is going to be, what your string column length is. Same idea. But the comparison. So when you say, give me vectors that are similar to my vector, the key is that it was the computation used to create the vector in the database is the same computation that you're using to create your vector that you're using to supply.
I'm still trying to figure out how to make this thing go away. Sorry. Okay, so yeah, it's very complicated. I'm not going to pretend to understand it, but yeah, it's kind of foundational though, and hopefully at some point I'll figure it out.
So in that example, the entire string description, that single one vector.
Yeah, and it makes sense because that's the thing that you want to compare text to. So yeah, now that we've embedded it, I'm gonna import the prompt. So this cool thing about LangChain is you can import this hub thing, and then you can just pull a prompt from Langsmith.
Nice.
In this case, I just pulled this prompt here. You are an assistant for question answering tasks. Use the following pieces of retrieved context to answer the question. If you don't know the answer, just say you don't know. And then, there's a question and the context, which is what's going to be loaded from, it's going to be the Alice in Wonderland from the embedded database. So that's the prompt that we're feeding in. And then we define this QA chain. This is basically just the same thing that we did, except it looks different because we're using a retrieval QA chain to retrieve from the database. And so I just ask it a question. The question is, who is the author? And again, I kept it intentionally vague because I didn't want it to get information from my prompt. I wanted it to get it straight from the context that it had gotten. So if I run that, it comes back and it says the author is Lewis Carroll, who is the author of Alice in Wonderland. So that works, and that's kind of cool. And the good thing about having that in the Chroma database is we can now retrieve it later, and we can compare text to the text that's in the database. So that's a lot. but yeah, definitely good stuff in there. Here was another prompt that I thought was kind of cool that I also got from Langsmith, the Langsmith website.
I'm sorry, can you, if you ask like a question more specific about the story, like inside, like what's the effect of the mushrooms?
Yeah.
She eats
Yeah.
mushroom, yeah.
What do the mushrooms do?
Yeah. Just to. That's good.
I don't know. That's a good question. The mushrooms serve as a platform for Alice to stand on and to see what is on top of them. In this case, she discovers a large blue caterpillar on top of the mushroom.
But she eats them too.
But there's a different one.
There's like a
There's a cake
cake and then a drink.
and then a drink.
Oh,
Yeah.
it's not a mushroom. Okay.
Yeah.
I thought it was mushroom.
Well,
I
that's
thought
in
every-
real life.
I thought it was about drugs in this book.
It's
so-
medical.
Yeah.
Oh, it's a cake, so.
That's okay. Yeah, so there's a lot of optimization that you could do here. Obviously, I'm not touching on any of it, but yeah, there's as far as like you could choose to split the document differently or chunk it differently.
Mhm.
You could choose to use a different embedding. You could choose a different database. There's like a lot of things that you could tweak here to optimize. So
I wanna go in and randomize some of those dimensions on the vector, just like change 3 of them. Out of
Chaos.
1,000.
yeah,
Mutation.
that would be
How does
perfect.
that affect, you know?
It would probably make it not work so
Yeah,
good.
yeah, yep.
But
I,
like, would it be at all recognizable if we change 1, you know? Like,
yeah, that's a good question. I don't know.
That is a really good question.
With the number of dimensions that there are,
Yeah.
if you change one.
Yeah. But-
Well,
Like-
if it's a foundational,
It's a sign.
Yeah.
yeah, if it's foundational, like it could,
Well, you'd also have to go through and change every single one because each vector is just a part of the whole book.
Yeah.
So if you just change one, it might not make a difference, but if you change every, the same element at every vector, maybe it might make a difference.
And what, have you tried to tweak with the chunk size and the chunk overlap? How different it is? Is it?
Yeah, I tried doing that a little bit. I didn't see anything noticeable. It's something that I'd be more interested in, for sure. From what I understand, you always want to have some chunk overlap, just because it helps the LLM to like align, to connect
Yeah,
the
yeah,
different-
dots,
and
yeah.
not lose concepts, not get a concept
Like
that's
we need
split
that
in
too,
half,
yeah.
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 It's kind of the same thing when you train a model, and you have to decide how many times you're gonna train it. And if you train it too often, too much, it's going to be too sensible, and it's not good. But if you don't train it enough, then it's not enough sensible. So you
Yeah.
have to find the right.
Yeah,
settings.
that's the problem of overfitting. So yeah, if you train it, and this kind of goes into like machine learning in general. If you train a model on a specific data set and you have it match that data set perfectly,
Mhm.
if you introduce new data, it doesn't know what to do with it because it was trained so you want it to be general enough that it can classify new information, but you don't want it to be you want it to be specific a little bit. It's another thing where you could optimize a lot. And admittedly, I don't know a lot about it. But I do know that's a very common problem for sure. That's called overfitting, if you're interested. So then I just want to show off this other prompt that I thought was kind of cool, just so show you what you could do with it. Basically, here, let me load this up so I can show you what it looks like. So this is a citation prompt. And basically, this is something that somebody else wrote. It says you are a history teacher. You'll be provided with historical content about India. Your job is to refer the provided content and then answer the question. And then there's some rules. To answer the question, you must follow the below rules. One, the provided content will have one or more documents. Two, each document is enclosed within document and end document tags. Three, create the answer based on the provided documents only. Four, the answer should be as precise and concise as possible. Five, for each answer, cite the document name that was referred to. And six, at the end of your question, create a list of document names. So you can see that basically it's you have to be very literal with the model. And the more specific, the more descriptive you are, the more specific, the better results you'll get. And I just wanted to show this off because I thought it was kind of cool. So as context, I'm just passing in these strings, 2 long paragraphs in between the document and end document. And so you could imagine like that could be like a Wikipedia page or something that you get through RAG. And then we're gonna get the chain from the hub, which is here. And then we're going to call this, and then this is going to cite the sources. This is kind of a simple example, but just to kind of give you an idea of what you could do. And then we can inspect each chunk individually. And this is kind of like what a token looks like. You can see that it split everything up into tokens. For example, it found capital K and then Uru, because I think there's a question, yeah, what is the Kuru kingdom? And so these are just the parts of the sentence that it found significant. Mostly just individual words, but sometimes parts of words, which is kind of interesting.
Yeah, that's I don't understand chunking either. It's like K and Uru, like
Yeah.
why?
I don't know, but my guess would be like, for example, it found the capital K and it might say, okay, that's a capital word. So either it's the start of a sentence or it's a proper noun or something. I'm not a linguist.
I think that's very much what it is.
I don't really understand how it works. There's different tokenizers you can use. For example, OpenAI has their own tokenizer called Tick Token, I believe. I haven't tried that yet, but just with everything in LLMs, like there's many different implementations to do the same thing, whether it's tokenization, and then after you tokenize, you might chunk, or I think it's chunking first and then tokenize. Anyways, there's a lot of stuff to learn for sure. This is just supposed to be a broad overview.
I think it's usually chunks of tokens.
That makes sense. Yeah.
And the chunk is where the inference happens. Like with Solar, I can totally see this tokenization, why you would split on a case change.
Yeah.
And you wind up putting those 2 tokens next to each other.
Yeah. It's very interesting though. And I hope to get more into it at some point because I'd love to learn different chunking strategies and stuff like that. But so that's kind of it for the LangChain part of it. I also had some other stuff lined up. I want to show you how to do things without LangChain, just so you could see like a little bit behind the curtain to see like how that works.
Yeah.
But actually, I'm gonna grab a drink of water real quick.
Go for it.
I'll be right back.
Yeah. So yeah, I've obviously been doing a good bit of this as well, doing very similar things. But you can see what I said earlier, the instructions that Tim was giving in in his chat is very much just like these RAG motions of just giving instructions around a prompt. That's really all the RAG is. Does anyone have any questions at this point?
Okay. Did
You know what?
anybody
I want,
know where LangChain came from?
you know what? I don't have it. If anyone was saying anything, I just realized our speaker was off.
I don't think so because nothing was in chat.
Yeah. I apologize for anyone who was trying to ask a question.
For some reason, it's always hard to like do Zoom or Teams or anything because no matter what we do, even at my work, we have trouble with Teams. It's hilarious.
Yeah. Oh, Teams, I don't like.
Teams is interesting. Um,
Right.
all right, so yeah, I guess let's move on.
Is there a reason you chose LangChain instead of working directly with OpenAI's? Yes.
I just chose it because I'm still really new to LLMs. And so I like the idea of LangChain, which is like it's basically just a wrapper around other models. And it also it's good to learn like just the overall concepts, but there's really no reason to use it just other than like it seemed interesting to me. So I looked into it. But I quickly learned, but you know, especially if you Google LangChain, people will tell you you should just do things without LangChain. I'm sure you probably saw some of that. Because it's pretty easy. Like I said, this is all just like a thin wrapper on top of existing stuff. Like in the case of the chat message history, like we're just using a list. There's really no reason to use a chat message history object unless you want to do some specific things.
We've used it largely for the tokenization. And so it has a wide variety of options there from the token chunking to row, like just very easy to configure and switch back and forth. It also has like built-in PDF reader. It brings a lot of those common use cases into a single package.
Did you ever use it with non-OpenAI models?
We actually only use it for the tokenization, and then we go
Oh.
directly to the OpenAI or Claude.
Oh.
Generally, what we're doing is going through Bedrock for the different, Bedrock is the AWS standardized interface to all of the different LLMs so that we can easily switch back and forth between like OpenAI and Claude and Llama. But yeah, so they're separate for us.
Yeah, I mean, it's got a lot of helper functions
Mhm.
to inconvenience classes, but you don't have to use it. It's pretty cool to check out though. So to kind of compare like LangChain to how you would just do it yourself, there is I downloaded this notebook from this website called Prompting Guide, and I'm going to put all the resources that I found in here into the chat, just because I'm sure
Yeah.
that will be helpful.
And those will be helpful in a follow-up too, and I'll put them in this will probably make it up onto YouTube. And
Oh,
I'll
great.
put them in I'll put them in the description.
All right, perfect. Thank you. Yeah, so this is just a notebook that I downloaded from this website, and I need to make sure I install everything on here first. That would have been, I have to cancel this session. All right, let's try that again. What doesn't like me? Because I have too many sessions open.
Yeah, too much going on.
Yeah, let me close some of these. I haven't paid for Colab, so.
It looks like a nice service.
Manage sessions. Yeah, I like it a lot. It's really cool. And you can also, it also supports GPU CUDA stuff. I haven't tried that out, but it seems really cool.
Nice.
So yeah, prompt engineering basics. Still not sure how to feel about the term prompt engineering.
Yeah.
But
Well, there is some skill in knowing how to ask the questions for sure.
yeah, for sure. I should have installed this stuff earlier. Sorry.
No worries.
But you can see we're using OpenAI, their Python package instead of LangChain. We do install LangChain, but I don't think it's used here. And then python.env, so we can load the OpenAI API key into here so we can use it. So I'm just gonna do these imports, load the Oh, did I do this? Oh, whoops.
You just import OS. Oh, you
Oh,
do
no.
have,
Yeah, this isn't right. Hang on one second. I know what I did wrong. I needed to do this here. This is supposed to be OpenAI. And we're going to set the environment variable to that. And I don't think we need this other stuff. Because I'm using Google Colab Notebook, I'm using the secrets.
got it.
And so, yeah, it has to load it a specific way. So this is how you would set up a client in OpenAI and using their package. I don't know how I feel about this, the way that they did this here. But I guess it looks okay. So basically there's a function to set the parameters for the model. We select the model name, the temperature, the max tokens, which is the number of tokens it will output in the response, top P, which I'm not going to go into that right now because it's very complicated and I don't really understand it. Frequency, penalty, presence penalty, I don't really understand those. But we're basically just going to set those here. And then we pass the output of set params into the get completion function, which just calls the OpenAI API to get what's called the completion. It's just what the output of the API is called. It's also, you could think of it as like a response. I don't know why completion just seems so weird to me. But it just calls it using OpenAI chat completions.create. Here's an example. So before we were working with lists of messages, in this case, we have a list of messages, and this time we have to define, we define it in a dictionary. So the role is user because it's a user message. And then the content is the prompt string that we're passing in. The prompt that we're using is the sky is blank, and we're going to have it finish that sentence. Did I not? Oh, I didn't run this, though. Sorry. So the sky is what? The sky is blue. We get a response object, and there's multiple choices. I guess you could have more than one response message. In this case, we're just taking the first one, and we're getting the message and the content. So the sky is blue. We could try with a different temperature to compare results. So before we had the default temperature of 0.7. Let's see what it does with a temperature of 0. Okay,
That's beautiful.
blue and dotted with fluffy white clouds.
Very poetic.
Yeah, very, very interesting. Again, this is called zero shot. So we're just asking it point blank a question. It doesn't have any context, doesn't have any, it's not primed at all. This is also showing like, okay, you could have it summarize. So it's the same thing. We make a list of messages, and the only message in there is a user message with the prompt talking about antibiotics, their type of medication, everything, just giving it some context. Let's see what it says when we ask it to summarize. Explain the above in one sentence. Antibiotics or medications. Okay, so it summarizes it in a sentence. But the idea is that instead of using those human message and AI message and system message objects like before, we're just passing in this dictionary because this is the way that OpenAI understands a message. Basically, this is what a message looks like. And we could also ask it questions about text. Here, we're just manually passing the context. Yeah, there's nothing really interesting here that we haven't already covered, but this is just how you would do it without using LangChain, basically. Some more examples. I think there's something else here. You could have it do reasoning, which is kind of interesting. There's some advanced prompting techniques. So this is few shot prompting, where we basically give it a problem to solve, and then we tell it the answer, and then we basically are giving it examples. That's few shot prompting. There's chain of thought prompting, which we can basically have it explain its reasoning by first giving an example and then explaining how we got our answer. So yeah, this is just kind of
That's cool.
and let me show you where I got that, because it's actually a pretty good resource. There's this website called promptingguide.ai, and they have these notebooks here, which are kind of interesting. And I put those in chat. If you, I like this because like it really takes you through the beginning of like what are these, what are the parameters you're passing in, the basics of prompting, zero shot, few shot, just different like terminologies that are good to know. Yeah, so there's that. And then I did want to show you, oh yeah. So this is pretty cool. So one of the things you can do with OpenAI is you can give it a list of functions, Python functions, and then have it call, you could have it fill in the parameters for a function and call the function. Let me see if I can get that to work here. Am I running in there? So I have an example here where I defined a function to send an email. And what I'm going to do is I'm going to have OpenAI write a doctor's note for me and send it to my work so that I can call out sick tomorrow. Basically. So yeah. Load.env. Oh, from Python. Wait, hold on one second. Sorry, did I install this? I don't think I installed Python. Oh yeah, here. Sorry. Yeah, I got really into this over the last couple of days, trying to figure out like what you could do. Like, it's tricky though, because there's a lot of security concerns with like calling functions and stuff. You don't want to give it like secret information. But I figured it's just sending an email to myself. That probably is fine. So basically what we do is we create the OpenAI client here, or I pass the API key, and I'm just using OpenAI. I'm not using LangChain, and I define the send email function, which is this is just modified code from Google to send an email over OAuth. So it's going to ask me to prompt me for my OAuth. But basically, you can see here it makes an email. It takes in as input the sender email, the receiver email, the sender name, subject, and body. It defaults to 0 or to an empty string. So now that we have that set up, we need to define the function in a way that OpenAI understands. And so we do that using what's called tools. There's function tools. So this is a type function, and we're passing in a function. We give it the name of the function, which was send email when we defined it, and a description, compose an email and send it. And these are the parameters it accepts, and description of the parameters. And these are the required parameters. So we require a sender email, and we require a receiver email. So we have to create that, and then we pass that into the AI. So this is a modified get completion function, right? This is just getting a response from the AI, but I added some code here to if the AI wants to call a function, if it wants to make a tool call is what it's called, we get the list of tools that it wants to call, or the list of functions, and then we're just going to we're going to extract the function name from the response. And I just have this dictionary of available functions, and we're going to call the function. That's basically what it's doing. And it's getting the arguments from the response, tool call.function arguments. And we're just going to pass in. It's basically like a nameless function. You can think of it kind of like that. But when it does that, we have to append a special tool message just to let it know that it made a tool call. And so that's what I'm doing here. I know I'm kind of like going over a lot of stuff pretty quickly, but I figured it would be too long to try to explain every single line. And then we're going to get a second response after it makes the tool call, and we just stick that into messages also. And actually, I think this should not be, oh wait. I think, yeah, sorry. I have a modified version of this that I like a little bit better. But okay, so this is what it's going to look like. I'm going to open up my, oops. So this is, okay, so this is my alternate email. And we're just going to watch as it hopefully sends it. So I give it a message, a user message with the content, send an email from don't dox me, please. The subject should be doctor's note, and the body should be a doctor's note to let my work know.
I edit all that stuff out.
Okay, thank you so much. I really appreciate it. And so, oops. We get a doctor's note. Dear recipient's name. Sounds very official. I am writing to inform you that I will be unable to come to work tomorrow due to illness. I have visited my doctor and have been advised to take a normal human day of rest to recover. I will provide a doctor's note upon my return to work. Thank you for your understanding. I don't know if my boss would accept that personally, but yeah. So then we can see the response, the chat completion, which is it should have the function name that it passed in here. Yeah, so oh, maybe, yeah, sorry. I thought we have the function name. Function call. Anyways, this is a lot of stuff to do. I'm not going to go over every single detail. This is kind of just a demonstration, but I'm just going to ask it what I just asked it to do. You asked me to send an email. So that's that.
And that's just using the OpenAI APIs, not LangChain.
Yeah, that's correct. And that's all possible because of this tool definition.
Yeah.
And that's in the AI docs or the OpenAI docs. This is just, they trained it to understand this type of function definition so that it could write the parameters and then call it. So I'm calling the function locally, but it's filling in all the details from the AI, basically.
Is this the kind of approach that I saw some people doing bots for Terraform provisioning, where they made their DevOps teams would make say, I need a server that does this, and it expects it out and then says, and you say go, and
That's really interesting. That's something that I'm also kind of interested in. I just don't know. I want to make sure that whatever I do is secure.
Yeah.
For sure.
Well, that, and there's still the creativity aspect.
Yeah.
Well, yeah, it's got a sort of Git. It's like, I mean, I guess theoretically
Yeah.
you could have it also check in commit for that.
Right.
Yeah. Oh, maybe it
That,
wasn't even
that's
necessarily-
excellent point. Yes.
Maybe it was even just hitting the cloud API.
Yeah.
Was it?
It's possible.
Or somebody was doing that?
But you could just have it like just run like Bodo 3, like
Yeah.
and like just have a function. Actually, that was some stuff that I was messing around with also. Maybe I
It's the
can.
next generation of
Well, do you know what
IRC
other
bot
types
automation.
of tools there are besides like the function type?
There are, yeah. I haven't looked at them yet. One of them is kind of interesting that I've seen, which is basically you can have it run a Python interpreter. So it will take in Python code and actually run it and then give you the output of what the code would do. So yeah, there's a code interpreter, there's knowledge retrieval, there's function calling, which is what I was doing, and then there's supported files. I don't know what these other ones do, but my guess is they're probably going to be adding new ones all the time. And I just really like the function calling. I thought that was pretty cool. So what I'm kind of interested in doing is figuring out how to run an LLM locally. I don't think you can't run OpenAI locally.
No.
So you'd have to find an LLM that you could run locally. That way you would solve a lot of the security issues associated with that.
What's the website you were just a minute ago with the
Yeah.
function calling?
Here.
OpenAI.
Yeah, this is the OpenAI docs. I'll put this in chat.
Well, that's also part of the argument that Amazon is making for their Bedrock stuff, right? Because here,
The running locally is what Amazon is trying to do with Bedrock, so at least you're running it in your cloud. you have walls around what it's ingesting.
Yeah, a little bit more control over it. Actually, it's kind of interesting. There's a tool I came across, an application that I came across called LM Studio. I don't know if anybody's heard of it. I thought it was kind of interesting. I have it on here if it will work. Basically, it lets you download LLM models from Hugging Face, and then you can run them locally. This is what it looks like. So you could, and I think I put a link to this
Yeah.
in the chat,
Mhm.
but you can download, let's see, what do I have? I have Gemma, which is basically Gemini. And it can do, so you can do chat in here. I think I was trying to get it to draw a picture of a fish. It didn't, because I was trying to work with stable diffusion.
Yeah.
But that didn't seem to work. But basically, you just load up the model, and you have this chat interface that you can do, or you can run a local server and make API calls to it locally. I think this is kind of cool because there's some useful Python code here. And I just have started to scratch the surface of this, but we could say like, let's start a new chat. We'll say, write a Python, right? A Python hello world function. Oops.
I think that what we'll most likely see in the near future is more specialized models to run locally that are less general and more purpose-built, like for coding, like having a model that specifically generates Python code and knows like application logic.
Yeah, that is super because there's so many models out there.
Right.
It's hard to know which one to use, and they all do things slightly. Yeah, for sure. And that's really
Because that'll have a much smaller footprint and would be able to be run. They talk about running models on your phone, very
Yeah, that's crazy.
specialized. But you're never going to run OpenAI on your phone. But specialized stuff is absolutely doable.
And if you can train it with your company's code and
Mhm.
your libraries, then all the developers that are churning this stuff out are gonna use all the code that you've already written and not just go and find something to download it.
Yeah, and actually, so it's funny you were talking about the AWS stuff. So I was building an AI assistant to try to just get it to do things, see what it could do. And one of the things I had it do was just list my S3 buckets. So you can say, oh, let's see if I can get this to work real quick because I thought that was kind of interesting. So I installed Bodo 3, which is the AWS Python client. Lets you make API calls to AWS over Python. And I have my environment secrets set up here. And so as soon as this is done, I'll show you what it looks like. Basically, you can use natural language to say like, show me all of my S3 buckets, and it will give you the list of S3 buckets. I don't know if that's, well, that's not necessarily very interesting, I don't think, because it's basically just what we've already done. But just to show you how you could do it, I just defined this definition here, right, into this tools list here. So any function you add, you just need to add a new definition for it. So that's basically what that looks like. And then, yeah, maybe I won't do this right now because we've already seen it. I'm stalling, trying to see how much more time I could take up. Oh, there's one more thing I wanted to show, maybe the Redis stuff.
What might be interesting is to take the API for Bodo 3, the API for AWS is all REST. It's a REST client, REST backend, and I bet there's a Swagger or like an open API definition for it. Transform that into all of the function call structure,
That's smart.
and then just tell it, and then you could just ask it, describe this random resource for me instead of having to dig through all the APIs and figure out what the switches are that you need.
Yeah, they should have that as a tool, like
Yeah.
a Swagger definition, and that way you just refer to the Swagger thing. And it's,
Yeah. But they actually, they have it documented as such, but not quite, not directly as an open API.
No, but I'm saying OpenAI,
Yes.
they have 4 tools. One of them, they should, the next one, I mean, that's way more useful than a function call, I think, because you're
Yeah.
always writing code against
APIs.
APIs.
Yeah. I think that'd be great. Yeah.
Yeah.
Yeah, we should ask them to do that.
Oh, we should just do it.
Yeah, the AWS thing was a crazy idea. I had an IRC bot that I wrote in Python, Twisted,
Years ago, that the number one job was what are the current servers behind my load balancer for each of the things? Like, oh, I got to find out what's going on with the machine. What number are we up to from the generation? So like, oh, okay, this is server 12 and 13 that are currently behind the load balancer. And we put that on our IRC channel so all the developers could ask it like sanctioned questions.
Nice. That's a good idea. Very cool. Yeah, I don't really have too much more to show. I just wanted to show, if you guys are interested, the Redis thing, just because it kind of shows a little bit more information on like, if I have it, do I have it? Oh, wait, no. It was basically just this notebook, just to kind of show you like what the vector database looks like. That's a very long vector. You can create an index on the vector. This is very complicated. I don't really understand it all, but it will do that for you. Oh, wait, actually, there was one thing I wanted to show, which is, I think I wanted to, hang on, sorry. Did I have it here? Yeah, Redis stack. So basically what I did was I installed Redis locally, and it would help if I ran it. I just want to show you like what the table looks like, because I thought it was kind of interesting. But yeah, that's pretty much it. I don't really have too much else.
Nice.
Yeah, that's a good presentation.
Thank you. I tried to put a lot of work into it.
Yeah, choose.
Thank you. And I also went down like a huge rabbit hole. Like, I'm sure you can imagine. Because yeah,
There is a huge rabbit hole to go down.
yeah, it's funny. Actually, I didn't think I was going to have enough to talk about, and then I got into it. I'm like, oh wait, there's a lot of stuff. So this is kind of like how you would, another way that you would embed a document and put it into the vector store. Basically, you have this list of metadata and a corresponding text here. And so basically what it's going to do, ignore this. This is me calculating something. Basically what it's going to do is it's going to, from the LangChain community, it's going to import the Redis client. It's going to use the texts, and it's going to use the OpenAI embeddings object. And I think it would help if did I do this? LangChain community. Sorry, but oh yeah, it's already here anyways. So this is kind of like what it looks like when you import the embeddings in. It creates basically an index. And there's some interesting documents here, like the number of documents is 5 because we had 5 texts here. And then yeah, this is just like the different stuff you can get, which is kind of interesting. You can query it. So like you can do a similarity search, which is what you were talking about, where you give it a text and it looks for text that's similar to it. And it measures it in what's called a similarity score, which is basically a number from 0 to 1. 1 would be like perfectly similar.
It's actually -1 to 1. Well,
Oh, yeah, yeah.
it depends on the computation. The most common is cosine similarity, and that goes from -1 to 1.
Yeah, you're right. Because -1 is like totally opposite. And this is just like showing what it would look like, so you can get the similarity score. So if I search for foo, because there's 3 texts that have foo in them, it will return, well, this is distance. So there's a concept of distance and then similarity. Distance is just one minus similarity. So they're two sides of the same coin. And yeah, that's just what it looks like. I thought it was kind of interesting. This is a notebook you can download from the Redis website. And I think I put it in the chat. If not, I can put it in there. But yeah, that's it.
Cool. Well, thank you very much.
Yeah.
It's awesome.
Yeah, it was fun to learn it all.
Yeah. No, I've been having a ball with it.
Yeah, for sure.
I'll do it now.
Yeah, the trick is having a clean set of data to work with. It is most powerful when you have this set of things that you want to ask questions about. Like one of the prime use cases is online documentation. And we have gone through for at least one client, vectorized all of their documentation and then used that as the RAG for the LLM request. So you ask a question. This is how do you set up a VPN in whatever context the documentation is for, and it returns out of the vector database the things that are relevant to setting up a VPN, and that documentation is fed as a RAG into the LLM request along with your prompt of how do I set up the VPN, and the LLM comes back with here you go. And
Yeah.
so the other part of that is when you're indexing all of your files into the vector database, to have a reference, have a column that is, this is the file that came from. So you can link back to the file when you retrieve those chunks. But yes, it is a vector per chunk.
Yeah, very interesting stuff. I'd love to learn more about vector databases and also chunking and stuff. And so there's a whole rabbit hole there, I'm sure.
Oh, yeah, I'm sure.
But yeah, that's it.
Awesome.
Is it okay if I stop sharing? Okay.
No, you must,
I must
you
share
must
forever.
continue.
Cool stuff.
Cool. So online, anybody have any questions?
No, I'm good. I'm just following along.
Yeah. Sorry, our speaker keeps turning off.
Oh.
I caught the end of that statement.
Oh, I just said, no, I think I'm good. Just following along, going through made a gist of the notebook and just going through it.
Cool.
Yeah, there's a lot of example Python notebooks out there from that prompting guide website, from LangChain website, documentation, and the Redis documentation also. So like there's a lot of stuff to use as a basis. A lot of good example code out there.
By the way, for the Redis notebook, that's on the Redis vector database. Is that example on there or?
I think so. Yeah, let me check here. Yeah, it's this. I don't know if you can see in the chat. There's a link under Redis vector store. It's the GitHub link.
Redis Ventures.
Yeah.
Okay, it's the vector similarity with Redis. Yeah.
Yep.
Notebook. Maybe. Yeah, I think I could just clone this repo and just walk through it.
Yeah.
Absolutely. Yeah, I'm gonna have to take another look at it also because I just kind of glanced at it. My eyes glazed over.
Yeah. Yeah. No, it definitely takes some time to get your head around how this is working, what this really looks like.
I'm gonna get another drink of water.
Absolutely.
Oh, actually, there was one thing I did want to say.
And one more thing.
Is it
This
dead
is-
body free?
What's that?
Is it dead body free? The one?
Yes.
Yes. So have you guys ever heard of King's Jawbone?
No.
This is something that I've kind of been very interested with lately. It's a notoriously difficult literary puzzle. Basically, it's a murder mystery with 100 pages. All the pages are out of order. And it's written in a very obfuscated way. And to my knowledge, only a few people have ever solved it. It's very difficult. I was wondering if it would be possible to have
I
an
bet.
LLM solve this.
I bet. Yeah.
So that's something I'm going to try to research in the future. I don't know if it's possible, but I'd love to find out.
How
Yeah.
old's the book?
1920s-ish.
Public domain.
It
yet?
is public.
It is, yeah, there's a text
That's
file.
definitely public domain.
Yeah,
Yeah, 34, 1934.
okay, so that's right on the cusp there.
Yeah.
But I know that they have just raw text files of that because I have one also if you search for it. But I thought that was very interesting. So
That'd be, yeah.
I tried to ask ChatGPT, GPT-4 to do it, and it just said it didn't know.
Yeah.
So that's crazy. Only a few people have ever solved that. And one of
And if they didn't write about it online, then people don't know.
Right, exactly. It's not like they're going through and indexing all of the Gutenberg project.
We mean, aren't they? That's exactly what they're doing.
I would, well, yes, but are they actually indexing all of the content?
Well,
Okay.
part of it is the book.
Yeah.
Part of it is like, yeah, is the book.
If they were, then the question probably would have been answered.
Well, they would also have to know that this book is not written in order. And the
Fair.
obfuscation, whatever.
You
else-
might have to give it some context. Tell it, say, this book is written out of, the pages are out of order and is a murder mystery.
Yeah.
Can you put the pages in order and
Yeah.
solve the mystery?
Give me a timeline.
Yes, yes.
I need the name of the book.
Yeah. I just thought it's crazy because there's no published solution for the book. Nobody knows. In fact, there's dedicated subreddits of people trying to figure it out. And
So that's CAIN Jawbone.
yeah, and I put that in chat.
It's like the Voynich manuscript.
Was it?
What?
The Voynich manuscript. It's Middle Ages or or 15 to 1600s. It's written in a code,
All right.
and nobody's quite sure if it's a code or complete gibberish.
Awesome.
That's so interesting.
It'll be funny if somebody just generated some random piece of text,
Right.
coincidentally to be a message.
Yeah, so it's all like illustrated and everything.
Oh, that's wild. Some madman's.
Yep.
They had psychopaths back then.
Oh, yes.